So the router is to the network, what the GPS is to the driver, right? So as an Uber driver, you know what the GPS does. And if you're not an Uber driver, you can guess what the GPS does. It gives directions. That's basically it. It plots a path for you, right? It selects the best route for you to get from where you are to your destination. So you input your destination, and then it draws the path for you on the map, right? Same principle applies. That is basically what routers do. So the routing involves two basic activities. One, determining optimal routing paths. Two is transmitting data packets through different physical networks, right? And so, yes, to determine the path to route data packets, the routers, they have to maintain and use certain things called routing tables. And now, what a routing table is a list of destination addresses, right, or destination networks that correspond to the physical interface name of the router. So we discussed MAC tables before, and the MAC tables, we said that they store the MAC addresses. The switch has these MAC tables and stores the MAC addresses of all the computers on the network. So if I'm sending a packet on the same network to another computer on the same network, it will confirm that, oh, the MAC address of this destination maps to this person on the network, and then it forwards it directly to the person. The router, does this, but on a larger scale. And so instead of using a MAC addresses, it uses what are known as the routing tables. So instead of using MAC tables, it uses routing tables. And so if the destination network mentioned in the incoming packet is found in the routing table, the router forwards the packet to that corresponding interface, wherever it may be. Maybe a laptop or a server or a desktop or even a mobile device somewhere. But if the router is unable to resolve that path, it drops the packet. Like you type in the location, it doesn't exist. You can't take the passenger anywhere. You can't take the passenger somewhere that doesn't exist. You drop the packet. And when the router forwards the packet to the physical interface, it transmits in the form of a single frame. And the frame contains the physical address of the next hop. Hop. What is hop? The hop represents the next router, which is the changeover point through which the packets travel between the source and the destination. I'm reading for you, but I understand. Let me explain. So, the network is made up of a lot of routers. There can't be just one router on the network, right? It's like having one road. Imagine there was just one road, the whole world, wherever you wanted to go, there was one straight road to get there. That doesn't even sound logical. It doesn't work like that. So yes, you're on one road, you curve to another road, straight, left, right, up, down. You meet at different junctions, have to make different curves at different intersections, right? So in that sense, you need a lot of routers. So the packets will move from router A to router B. Router B will pass it to router C. And that goes on and on and on and on until it gets to its destination. Right? So the hop simply represents the next router. And the hop may also be the final destination node or another router which executes the same switching process. And so that's basically it. That's basically it. It's all about forwarding the packets over the network through an optimal routing path from point A to point B, but through routers known as hops.